Javelin throwing is one of the most demanding sports in track and field. It needs very complex muscle coordination and accurate timing. The male thrower approaches the throwing line with a speed of 6 meters per second. After the touchdown of support leg, javelin is accelerated up to 30 meters per second with elastic muscle work of the whole body. This so-called delivery phase takes only 100 milliseconds. Javelin release speed is the most important factor affecting the throwing distance. For example, 90 meters throw in men's javelin requires a release speed of 30 meters per second. An increase of 1 meter per second in release speed means about 5 meters increase in flight distance. Javelin release angle means the flying path or the center of mass of the javelin at the moment of javelin release. In theory, the optimal release angle for javelin is about 40 degrees. So 30 degrees is too small angle and 50 degrees is way too much. But for the thrower, it's usually easier to produce higher release speeds when the release angle is smaller. That's why, in practice, the optimal release angle is from 35 to 40 degrees. Javelin flight with different release speeds and release angles can be tested with javelin gun. Test results show that, for example, when increasing release angle from 33 to 36 degrees with the release speed of 28 meters per second, the throwing distance increases about 2 meters. The deviation between release angle and attitude angle of the javelin is called attack angle. This angle should be usually as close to zero as possible. Otherwise there will be an extra air resistance which decelerates the speed of the javelin. The final flight distance is always an outcome of release speed, release angle, attack angles and aerodynamics as wind conditions and a javelin model. Javelin release parameters can be measured with three-dimensional motion analysis. Analyzing process includes two high-speed cameras rolling at 200 frames per second. These cameras are connected to the computer with Ethernet cables. For accurate analysis, the throwing area must be calibrated. The calibration is done usually with 4 poles and 8 calibration balls. The accurate location of the calibration balls is measured with tachyometer. Reflecting markers are used in javelin for analyzing the javelin movements. These markers can be seen better using extra lights, which are parallel to the shooting angles of the cameras. After each throw, software automatically finds the reflecting markers on the video. Then software calculates desired variables of the javelin release, such as release speed and release angle. By using more markers located on the joints of the thrower's body, also the whole body movements could be analyzed. To generate high release speed, thrower must brake efficiently with his support leg and transfer the energy to the javelin. Ground reaction forces produced by the support leg are enormous. Top-level male thrower horizontal force is over 5,000 newtons. The vertical force of the support leg is easily over 7,000 newtons. So calculated total resultant force is about 9,000 newtons, which stands for over 900 kilograms strain to the support leg. These forces can be measured with high-end force plates attached to the ground of throwing place. These plates measure forces in all 3 directions with a sampling rate of 1000 Hz. With separate force plates, forces can be measured for both 2 last steps of the throwing performance. Biomechanical feedback such as release parameters of the javelin can be presented to athletes and coaches right after each throwing performance. This gives a good possibility to discuss about technical details and to correct possible errors in throwing technique in the same training session.